Welcome again all viewers. We are here to discuss about the paper Networking Technologies, and the paper topic is Physical Layer, Data and Signals. And after reading this, you will be able to understand what are the different type of signals and what are their different characteristics are there. There are the data analog signals and the digital signals are there. So after reading this, after listening this video, you will be able to understand these two things. So topic is physical layer and data and signals. And if you remember from the previous class, this image were there. So this image was there, and there are the 7 layers of OSI model are we described in the previous class as well. So we are on first layer, that is the physical layer, and I also let you know, like, we will discuss you like in detail in some later on classes one by one. So first we are discussing this physical layer, and we are talking about the analog and the digital data. So see, one of the major concern for the physical layer, if you remember, it lies in the moving the data in the form of electromagnetic signals across the transmission medium, whatever the transmission medium we are using. So say for example, whether you are collecting the numerical statistics from the computer, or you are sending some image, you are sending some animated GIF pictures, or you can say you are causing a bell to ring at a distant control center, you are working with transmission of data across the network connections. Whatever the type of data you are transmitting, generally the data usable to a person or application are not in the form that can be transmitted over the network. ऐसा नहीं है कि मैंने पिक्चर बनाई और पिक्चर मैंने एज अ इमेज उसको सेंड किया तो ये एज इट इज ही ट्रांसमिट होगा. इट्स नॉट लाइक दैट. So this type of data is not usable like to a person or application, are not in the form that can be transmitted over the network. So like you cannot, for example, roll up a photograph, insert it into the wire and transmit it across the one station to the another station. However, you can transmit the data in the form of encoder. By using the encoder, you can create a stream of bits, that is the 0 and 1. And that tells the receiving device, that tells the computer how to reconstruct the image of the photograph from these 0 and 1. ये आपको समझना बहुत जरूरी है कि whatever the type of data we are transmitting, that data is not transmitted as it is. Not as it is. We are sending the videos, we are sending the pictures. आप normally करते हैं ना, आप you are attaching image in an email. So as it is not transmitted. So it is converted into the 0 and 1s, and then so that it tells the receiver, okay, that is the device which send the data in the image, and how to reconstruct that image of the photograph by using these 0 and 1 streams. But even 1s and 0s cannot be sent as such across the network link. They must be further converted into a form that transmission media can accept. So transmission media work by conducting energies along the physical path, and so a data stream of a 1s and 0 must be turned into energy in the form of electromagnetic signals. So what it is means to be transmitted data, it must be transformed into the form of electromagnetic signals. I hope it is clear to you all that whatever the type of data we are transmitting, that data must be transformed into the electromagnetic signals. Therefore, it's not easy ना कि आप समझ रहे हैं कि हाँ हमने डेटा भेज दिया और पिक्चर भेज दी और हमने वीडियो भेज दिया. वाओ, दैट्स लाइक इट्स नॉट इजी लाइक दैट. आप पूरे दिन व्हाट्सएप पे इधर उधर वीडियो फॉरवर्ड करते रहते हैं और मेल में आप डेटा सेंड करते हैं. इट्स नॉट इजी लाइक दैट. So what type of data are there, what type of signals are there? So both the data and the signals that represent them can either be of analog or digital form. So what is the analog and what is the digital data? Data can be analog or digital. Okay, like for example, analog data is the human voice. I am speaking, that is the analog data. And when someone speak, it is also the analog wave which is created in the air, and it is captured by the someone speak, and then it is captured by the microphone and converted into the analog signal, and then it is converted into the digital signal. Similarly, digital data example is like if you are transmitting the data, and that digital data it's stored in the memory of a computer in the form of zeros and ones, and then the data is converted into the in the digital signals when it is transferred from one position to the another position, or from one computer to the another computer. It is modulated into an analog signal and then sent through a transmission medium to another computer. So that is the analog data and digital data. Now, like the data, they represent the signals as well. So signal is also, just wait. Yes. So signal is also represent as either the analog signal or the digital signals. So analog signals and digital signals is what? An analog signal has infinitely many levels of intensity over a period of time. It is just like represent, we will discuss later on as a sine wave. So what is the analog signal? Analog signal has infinitely many levels of intensity over a period of time, and as the wave moves, I can show you the picture. This is the image. This is the picture of this analog signal. This is the wave. So as the wave moves, say for example, this is the value A and this is the value B. So it is moved from value A to value B. It passes through and includes an infinite number of values along with its path. Say its time t0. It starts from here, and it's moving on like with a different amplitude and different frequencies. So along this path, it has different values, and it has infinite number of values. This y-axis represent the values, and this axis represent the time. So as it crosses, its values are continuously changing. And a digital signal, you can say, this is on the other hand, this is the digital signal is there, and the digital signal can have only a limited number of defined values. Like already that is the 0 and the 1. It has only these digital signals can have only two values, that is the 0 and 1. So the simplest way to show signal is by plotting them on a pair of perpendicular axes. These are the x-axis and y-axis, and vertical axis represent the value. As you can see, this is the value, and this horizontal axis represent the passage of time as the time goes on. So the curve represent the curve. This is the curve. This is the curve representing the analog signal is passing through an infinite number of points, and the vertical line of the digital signal, this is the vertical line, is however demonstrate the sudden jump of the signal makes from value to value. Like this is like say for example 0, this is 1, and again this is jumping from like positive to the sudden negative value. So this is the it demonstrate that analog signal and the digital signal, that is the difference between both of these. So signal can also be analog or digital, but analog signal can have infinite number of values in range, and the digital signals can have only limited number of values like 0 and 1. I hope it is clear to you all, because it is very important to understand how this signals is this data is transmitted, that analog data and digital data is transmitted into the analog signals and digital signal. In the later on classes, when we will discuss about the data link layer and network layer. At that point, you must be remember these things very clearly. So signals in data communication, we commonly use periodic analog signal and non-periodic analog signals. So both the signals can have two forms, like analog also and digital also. This is the meaning of periodic and non-periodic, and we can say this non-periodic signal as a aperiodic signal as well. You can say non-periodic or aperiodic is same. So periodic signal, complete a pattern within a measurable time frame. That is called the period. So you can see like this. This is the periodic signal. This is the complete pattern. Say this is like this. At this point, this complete one. This start from this and it's complete this time. Sorry, at this time. So at this time, it's complete one circle, or you can say one pattern. So that is the meaning of this. So periodic signal complete a pattern within a measurable time frame. That is called a period, and repeat that pattern over subsequent identical periods. This is like this. This is repeatedly continuous going on. And the completion of one full pattern is called cycle. This is the one cycle. Again, it starts here and it's complete this. So this is the second cycle. This is again starts from here and ends like here. So this is the third cycle at this point. So the completion of one full pattern is known as a cycle. While in case of aperiodic signal, it changes without exhibiting a certain point of time. It's not showing like certain. It's not showing like a definite pattern, and that cycle that repeats over time. So both analog and digital signals can be periodic or aperiodic. So in data communication, however, we commonly use periodic analog signals and aperiodic digital signals to send data from one device to the another device. So this is periodic and aperiodic signal. I hope it is clear to you all. And I already told you that aperiodic signal or the non-periodic signal, both is the same term. You can use them interchangeably. Next, this is the sine wave. Like analog signals, as I told you, like an analog signals like can be classified as a simple signal or the composite analog signal. What is the meaning of simple signals? Simple analog signal or sine wave that is cannot be composed into simpler signals. Like this is the one signal and that is a simple signal. Now it cannot be composed into the different parts. So that is the meaning of sine wave. And a composite signal is what? Composite signal is composed of multiple sine waves. Multiple sine waves means multiple sine waves. This is the one sine wave. This is the another sine wave. This is the another sine wave. These are the meaning of different sine waves are there. So sine wave is what? Basically, sine wave is the most fundamental form of a periodic analog signal, which is visualized as a oscillating curve. You can say this is like what is the meaning of oscillating curve? Like this. This is just like pendulum. Now, say it is just like pendulum. And it is at this center, this pendulum is this, and it is oscillating from here, then again goes here and then come back. That is the meaning of oscillating curve. So that sine wave is the most fundamental form of a periodic analog signal, and it can be used as a simple oscillating curve. And this oscillating curve, changes over the, course of a cycle. Like, say, for example, this is one cycle and this is another cycle and this is the third cycle. So it goes on. And each cycle, consists of a single arc about the, time axis. This is the value and this is the time axis. Okay. So this follows like this, and time is passed. As the time passes on, this wave goes on further. And we can calculate this, sine wave as well. Amplitude we can calculate frequency. There is time period. There are the different terms related to this, sine wave. But before going with that, there is a amplitude term is there. So that is the, peak amplitude. Peak amplitude is what? There may be a question, calculate the frequency, calculate the time period. Starting from this is known as a, peak amplitude. So peak amplitude of a signal represents the absolute value of its highest intensity. This is the highest intensity, of this, sine wave, and that is proportional to the energy it carries. Whatever the energy it carries, it is, equal to that, highest value of this absolute highest intensity of this wave. So for electrical signals, peak amplitude is normally measured in volts. So this is about, amplitude. Similarly, we will later on discuss about the frequency and time period as well. So I hope it is clear to you all, like what is the analog data and digital data, and what is the difference between analog signal and digital signals as well. And later on we will discuss frequency and period as well, because in the later on classes we will discuss. I hope you understand this, and thank you for watching this video as well.